Hello and welcome. So this is a continuation of the previous video where we find how many numbers under 1 million, when you sum their individual digits, it adds up to 16. So not all of us have learned about permutations and combinations, which was the method we used to solve in the previous video. So that's okay, because the other method we can use is brute force. Now brute force means that we're going to try every single number from 1 to 1 million. And what better way to do this than to use a computer? So today we're going to use Python programming language. But before we start with that, let's talk about one of the constraints when using brute force for questions of this type. And that is the computer does not recognize numbers the way that we do. Say if I give you a number like 123, you know that the hundreds place is 1, tens place is 2, the ones place is 3. But to a computer, it has no such it doesn't know this kind of things. It stores the number 123 in binary form, and that means the number stored in the computer is actually 1111011. Okay, it has no bearings on thousands place, hundreds place, 10,000 place. No idea on this kind of things. Okay, so the workaround to this is we have to store the number, say 123, as separate characters, or what we call a string. Right, a string is a collection of characters. So I'm going to store 123 as 1, 2, and 3. 3 characters, if you like. It could have been A, B, and C, but it just happens to be numbers. And what we're going to do is to pick apart the characters later on, turn it back into numbers, and add them together. So that is the way we're going to do our brute force today through programming. All right, so let's get started. First of all, if I want to run through all the numbers from 1 to 1 million, I will need a for loop. Okay. So this for loop takes a number I, right, and increments it by 1. So I starts from, it starts from 1, and then becomes 2, it becomes 3, 4, 5, 6, all the way to 999,999. Okay, it doesn't go to the last number that's shown on the screen. That's just how computers work. Okay. Next, remember that we cannot deal with the numbers directly. We need to change it into a string. So how you can turn it into a string is just put str and then the number you want to convert into a string. So the number you want to convert is I. Right? Every time we have a new number, we want to turn that number I into a string. And it's also probably a good idea to store this as some variable, maybe A. Yeah. And then next, what we're going to do is, now that I have A, I want to look at the individual characters of A, right? Individual characters of A. How I can do that is I need another loop, right? To run through the length of A. So say A is a number that is like 4,444. So that's 4 characters. Then the length of A will be 4. And what we can do is, we want to add up each and every single character. Now, how do we access each and every character? That is known as A sub k. Yeah, A sub k. Because as k increases from, say, 0 to whichever number it stops at, it's going to pick out each and every character along the way. So this loop will allow us to run through every character, and what we want to do is add them up. And as I add them up, maybe I want to add it up to this thing called sum, which means that I probably need to, initialize a sum that starts from 0, right? And then it will just keep adding on, plus equals A sub k, right? And that's about it, right? We just need to check at the end if sum is equals to 16, exactly equals to 16. Watch out for the double equal sign. If it's equals to 16, I will say that that is a success case, and I would increment a counter by 1, which means I also need to start over here with a counter equals to 0. And that's it. This should, when I run this should give us the answer, but there's a mistake somewhere inside here, and that is, let's run and see. Okay, the mistake is this. Hey, on line 8, so this is line 8 over here, sum, over here, this line 8, there's something wrong. You're trying to add an int, an integer, and a string. Remember, we wanted to change our numbers into a string, and then before I add them back, I need to change it back into an integer. So you need to change this back to the integer just by doing this. Okay, so this should run, but before you run, it's always a good idea to time your code. See how long you took to run this, right? So I'm going to call start to be time.time. So time.time can be think of like you click stopwatch, right? When you click a stopwatch, you look at, oh, what's the time now? Okay, so it has a record of a time at this start point, and then I'm going to print. First of all, I need to print the counter. I need to print what's the number of numbers that add up to 16, and then next I need to print how long we took to run this program. Just type that very quickly. Time.time. Let's start. Okay, it's a bit below here. Yeah. So what I did over here, let me maybe scroll this a little bit, is this, right? I actually called time at the start here, start, right? So maybe it will ask the computer what is the time now. Maybe the time now is 4 p.m. exactly, right? So it makes a record of 4 p.m. and stores it in start. And then when after the program has run, I call time.time again over here, right, at the bottom here, so that it will ask the computer what's the time now. And maybe the time now is 4 p.m. and 10 seconds. So I take 4 p.m. and 10 seconds minus 4 p.m. That will tell me exactly how long this program took. Right? It's a good idea to always do this in your programs. And let's run. So the answer we should see is 17,577 as per our previous video. So let's see. If everything runs well, we should get the answer. Yep, we got the same answer, but it took about 10.7 seconds. Not very good. Okay, so I was hoping that we can get it down to somewhere like 1 second-ish, right? It can be a bit hard because we actually have 2 for loops running, right? So you can think of like the for loops as like if you have 2 for loops, it becomes like quadratic. If you have 3 for loops, it becomes cubic, and then the time taken to run becomes larger and larger. So one way we can try to improve this is if I can add in a check over here, right? As we're adding numbers up, summing the numbers, each and every a sub k, each character, I could just do a simple check and say that if the sum is more than 16, then I can just say, hey, just give it up. For example, if I'm checking the number 9,999, right? After adding 2 9s, that's 18. That's greater than 16. I don't really need to add the rest of the numbers because I know this is more than 16. So we can use the this function called break. It exits this loop and tries the next number. Okay, hopefully that improves things a bit. So let's run. Previously was 10.7. Let's see how long it takes to run now. And 8.6. So that's like a 2-second savings. Not too bad, but I was hoping to bring it down even more. Now, if you have any, so you can go ahead and try this out yourself, or you can think of ways to make this run faster, maybe without running 2 for loops. Now, if you manage to come up with a way to get this down to closer to 1 second, let me know in the comments, or let me know. Maybe we can do this again with the better code that you have implemented. So I come to the end of today's video. Until the next one, I guess I'll catch you on the flip flop.